All right, so in today's lesson, we're going to answer the question, how do you calculate probability of events that are not disjoint or not mutually exclusive? All right? If they're not mutually exclusive, that means that they have overlap. However, in your first three questions, or 1 and 2 here, these are questions that are disjoint. They are mutually exclusive. So if you have 8 balls that are numbered 1 to 8 and they're placed in a bag, one ball is selected at random. What's the probability of drawing a 6 or a 3? Yeah, absolutely, it's 2 out of 8.
2 out of 8.
2 out of 8 would be 1/4 or 0.25. A card is drawn from a standard deck of playing cards. What is the probability that the card is an ace or a king? If you have any understanding about a deck of cards, the first thing that you should know is that there's 52 total cards. There are 4 aces, and there are 4 kings. So just 4 plus 4 would be 8 out of 52. I'm not going to find the decimal on that. I'm just going to call it 8 out of 52. All right, well, 2 part B says...
When we do like our work and stuff, do you want us to find the decimal?
No, it doesn't make a difference whether you find a decimal or not. So what is the probability? The card is a 4 or a 6. So probability that it's a 4, well, how many 4s will there be? How many 4s will there be? 4. There's 4. There's 1 of each suit. And a 6, 4 of those. So it's still 8 out of 52.
Still 8 out of...
Right, yeah. Okay, so if you have a standard deck of cards, what is the probability of randomly drawing a heart or a king? Well, it would be nice if you had a set of cards in front of you, or if you can look up the sample space on the internet or something. But all the hearts, well, there's 13 hearts, okay? So there's 13 of each set, and then there's 4 kings. So immediately, people want to say 17. However, one of these kings is a heart. All right? So if you're looking at the Venn diagram and you added up all the hearts, that'd be 13 of them, right? And then you would add up 4 of the kings. You see how you add this king of hearts 2 times? So if we take one of them away, so we take that one away, let's say, then we've added up the proper amount. Okay? So what you're actually going to do is you're going to take the probability of being a heart, and then you'll add the probability of being a king. Then you're going to subtract the probability that it's a heart and a king. So let's look at that. The probability that it's a heart is 13 out of 52. Actually, all of them are out of 52, so I'm going to write them with one denominator. So probability of it being a heart is 13. Probability of it being a king is 4 out of 52. And there's only one king that is a heart, so you're going to have to subtract that one out. 13 and 4 makes 17. And 17 minus 1 makes 16 out of 52. And I'm not going to reduce the fraction just to make it easier on us. Okay? So yesterday you were introduced with a formula, and it was a mutually exclusive formula. The mutually exclusive formula just says to find or, all you do is add probability of A plus probability of B.
Isn't this?
However,
We started writing yesterday.
yes, this is the same kind of formula as you were writing yesterday. So the OR problem tells you to add. However, look, this one has a subtraction at the end. You're going to have to subtract out the overlap. All right? Using the same, this is the same exact formula right here. And if you read it by using words, it says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B happening at the same time. All right, so the next page, let's start looking at some examples. So on this one, it tells us the probability of A is 0.6, B is 0.7, and A and B is 0.4. So probability of A or B is this formula, A plus B minus both.
0.6 plus
Yeah, so if you want to substitute in numbers,
0.7
0.6 plus 0.7 minus 0.4. 0.6 plus 0.7 is 1.3. I'm going to subtract 0.4, and you get 0.9. You could say that that's 90%. They have a 90% chance of being in either A or B. Okay? So we're going to jump right into a word problem. And it says in Woodstock, the probability that a person plays sports is 65%. The probability that a person is between these two ages is 40%. And the probability that they play sports and is between a certain age is 25%. So what's the probability that a person plays sports or is between these ages?
0.65.
So this is an OR problem. So we're going to say that it's the probability of A plus the probability of B minus the probability of A and B. So the probability of A is what number? 0.65. The probability of B is 0.40. And now we're going to subtract 0.25. 0.65 plus 0.40 is 1.05. And 1.05 minus 0.25 is 0.8. Or you could write 0.80 if you wanted to. It's interpreted as 80%. Okay, so what if we're missing a part of the formula? Well, I don't have much space on this paper to do this problem, so I'm going to do it on a Post-it. But I encourage you to either find some space on the paper, maybe up this way, or otherwise. Okay, so here we go. So it says A or B. Okay, it already tells me that it is a number, but I have the three pieces of the formula, A, B, and A intersect B. So let's go ahead and write down that formula, probability of A or B equals probability of A plus the probability of B minus the probability of A intersect B. So one fault that I find is that people don't want to write the formula. If you are that kind of, if you're trying to be that kind of learner, it's kind of going to be hard to do these problems. Okay, these are formula-based problems right now, so just write the formula down and then plug numbers in. So here we go. Where does this 0.6 go? It says A or B, right? A or B. It's supposed to represent A or B. So right underneath A or B. The next one is 0.5. Where does that one go? Right underneath the probability of A. And the next one is the probability of B. It says 0.25, so that goes right underneath the probability of B. Now, we do not know what the probability of A and B is. So we can either leave it as probability of A and B,
Or make it X.
or we could call it X.
I'd rather stick to X.
A lot of people would rather stick to X. So now you have 0.6 equals 0.5 plus 0.25 adds up to 0.75 minus X. How would you solve that? Well, you'd subtract 0.75 from both sides. 0.6 minus 0.75 is negative 0.15, or 15%. But we all know that we shouldn't have a negative percentage, right? But it does say negative percentage equals negative X. So to
Subtract negative 1 on both sides.
divide by negative 1 on both sides. When you divide, that'll give you positive X equals positive 0.15. Therefore, what's our answer?
It's 0.115.
0.15. That is the probability of A and B. Okay? So maybe you found some space to do that work. That would have been example 3. You might could have put it up here somewhere if you wrote a little bit smaller.
So what is our formula basis?
Your last test will it's going to consist of this information.
Just all of this?
Yeah, just the probability stuff. Okay. All right. So
Did we not learn this earlier this year?
no. All right. So here we go. You ready? Since it's on the same piece of paper, I imagine it's asking me to use the same exact formula. Okay. So I don't really have to even read the question, and I know that it's asking me about this formula. Probability of A or B equals probability of A plus the probability of B minus the probability of A intersect B. Okay, now let's read the words. Where does this 0.35 go? Under the probability of, read it, A. It'll go under the probability of A. What about this next one? Probability of A or B is 0.8. So where does the 0.8 go?
To the left.
On the left side, underneath probability of A or B.
I just write the equation where I can see it and then point.
And do we have probability of B? So what do you want to call it?
X
Sure.
minus
Minus the 0.2 should be underneath probability of A and B. So 0.2. So now you're going to simplify this the way you always have. Linear equation. The only difference is that you have decimals this time. So I'm going to add these two terms together. They're constants. They're both constants, so I can add them together. So 0.35 minus 0.2 will be 0.15. So say 0.15 plus x. So what should I do to get x by itself? subtract 0.15, subtract 0.15. And I'm a big proponent of using a calculator when you're trying to do decimals, just because a lot of people find them a little bit confusing. So this will give you 0.65 on the left-hand side, but on the right-hand side it's x. So what is our final answer? X represents the probability of B, so yeah, you're absolutely right. 0.65 is equal to the probability of B. All right, so sorry for the lack of room to do those problems. Hopefully you were able to find some room somewhere on your paper to do that. All right, so in Mrs. Robinson's class, there are 12 boys and 16 girls. On Monday, 4 boys and 5 girls were wearing red shirts. If a student is chosen at random, calculate the following probabilities. Now, you could try drawing a picture. Would you guys like to see the Venn diagram before trying to use the formula? Maybe?
What?
Would you like to draw a Venn diagram, a picture of the situation, or you just want to try using the formula? Okay, so you want to try using the formula, so let's try to do it. So it's going to be the probability of B plus the probability of R minus the probability of B and R. So now we have to just read carefully. Probability that you have a boy in this class. Well, there's 12 boys and 16 girls. So how many people total?
0.12?
12 plus 16 is 28 people. So if you have 28 total students, what's the probability of picking a boy? 12 out of
28.
28. So 12 out of 28. All right. Now, how many people wore red shirts? It says 4 boys, 5 girls. So how many total? 9 people were wearing red shirts. Now, we have to subtract the boys that were wearing red shirts. How many boys were there that were wearing red shirts? 4, so 4 out of 28. In other words, it's 12 plus 9 minus 4 all over 28. So 12 plus 9 is 21. And 21 minus 4 is 17 out of 28. This is super confusing. We're just sticking numbers in for that formula that we're learning today. So you might want to write the formula every single question. All right, so here we go. Probability of girl or red shirt. So it's the probability of girl plus the probability of a red shirt minus the probability of girls that are also wearing red shirts.
Okay, 16 out of 28.
We know it's going to be out of 28. How many girls were there? 16. How many red shirts were there? There were still 9. 4 boys, 5 girls were wearing shirts, so red shirts, so that'd be 9. And then you're subtracting the girls that are wearing the red shirts. So subtracting the 5 girls that are wearing the red shirts. 16 plus 9 is 25. And 25 minus 5 is 20 out of 28.
20 out of 28.
That fraction does reduce. You can reduce the fraction. I'm just not worried about reducing fractions right now. Okay? Here's another formula that I introduced to you yesterday about complements. It's 1 minus the event that it actually does happen. So, example 6. If the probability of an event A happening is 0.73, then what is its complement? The probability of its complement would be 1 minus 0.73. Well, 1 minus 0.73 gives you 0.27. And again, the same thing works if you think about it the opposite way. If the probability that the event did not happen is 0.42, then the probability that it does happen is 1 minus 0.42, or 0.58. And we're going to still use Mrs. Robinson's example above to find the following. How many girls were there in Mrs. Robinson's class? Look up and read. How many girls? 16. So 16 out of 28. How many of those people were not wearing red shirts? Well, think about it. How many people were wearing red shirts? 9 people were wearing red shirts, right? So if there's 28 total students, you take 28 and you subtract 9, that'll give you 19 people were not wearing red shirts. All right, so now the probability that you got girls and not wearing red shirts.
16.
Wait a second. If it says you have 16 total girls, right, and you got 5 girls were wearing red shirts, how many were not wearing red shirts? 16 total, 5 red shirts. So you subtract those and you can get 11 were not wearing red shirts. So 16 total girls, but 5 of them were wearing red shirts, so 11 were not. So 11 out of 28. Okay? So now we are given the formula to find our next one. This formula says probability that it's a girl or a red shirt means I'm going to take the probability that it's a girl plus the probability that it's not wearing a red shirt, and then I'm going to subtract the probability that the girls that it's a girl and not wearing a red shirt.
Plus 19.
So 16 plus 19 minus 11 all over 28. 16 plus 19 gives us 35 minus 11 over 28. And 35 minus 11 is 24 out of 28. So there's a pretty good chance that you're going to have a girl that's not wearing a red shirt if you randomly select someone from her class. I'm sorry, girl or not wearing a red shirt. Okay, so the assignment's on the next page. I'm here to help.